Hey, mechanical systems design. Good to see you. I guess it's almost over here, uh, all but for the celebration. So it's been a quarter. We've come a long ways, and I just want to record this quick video to remind you of how far we've come. And one way to illustrate that is to remember back to the beginning of the quarter, just 10 short weeks ago, and imagine receiving the Project 4 description on the first day of class. I think most of us would have been baffled, right? We wouldn't have known where to start. But all of you just succeeded in completing that really challenging design task. And I think that shows how much you've learned in this short period of time. If we think back to the beginning of the quarter, most of us had not done any finite element analysis. And if you look at the way that your FEA skills have evolved from the first project through this last project, it has really come a long ways. And you've been thinking a lot about how to constrain single components to accurately capture what they'll experience in the real world, and to set up a problem to get the stress analysis results that you care about for a certain region of the component, how to use FEA sketches to check or improve your back of the envelope analysis and free body diagrams, and even how to use full assembly analyses to get accurate estimates of stress in complex loading scenarios and systems. And this is an amazing tool for you in your designs in the future that you now have. Most of us coming in this class also had very little exposure to electric motors. And I know for some of us at the beginning, this was a little scary, looking at all these equations and that we needed to manipulate. But we all worked through it. And by the end, in this last project, we were able to pick a voltage and a gear ratio so as to maximize performance in terms of mechanical power and avoid overheating. And that is really impressive. And this really helpful, useful scale motors are all around us. They're in lots of different mechanical systems, machines, robots, and products. And now we have this intuitive understanding of how they work, how current relates to torque and speed relates to voltage, and how to incorporate these components into new designs. And that's pretty cool. Many of us had relatively little experience with 3D printers before this course also, let alone having assembled and tuned our own printers, or had to do so under really challenging constraints. And by now, most of us are very good with these tools. We know how to design parts so that they are well suited to 3D printing, and how to analyze the typical kinds of shapes that we'll 3D print, how to slice them, print them, and then incorporate those in practical ways into mechanical systems. And this is another amazing tool that you have now. It'll help you with lo-fi prototyping and even functional prototypes for the years to come. And for most of us, this has been the first deep experience in short form technical writing. And probably for most of us before this quarter, we didn't think about writing as a way of thinking through something or improving our own understanding of it, or using writing to make our designs better. But based on the summary pages I've been reading over the past week, it's clear that you all have come just light years since the second week of class. And this is another skill that's going to be really helpful for you in the coming years. You're going to be able to better convince your peers and supervisors, your funders and clients that your designs are great in just a few words. And that is going to come in really handy. And of course, we've gone deep on an approach to design that incorporates ideation, simple theoretical models, computational tools, prototyping, and iteration in this creative design process. And we've especially gone deep on our understanding of the power of models for design. At this point, it's really clear to all of us, I think, that armed with just a few simple universal rules, we can do amazing things in design. For example, if we just focus on the concept of static equilibrium, we can perform free body diagram analyses to understand how a component is loaded and how that loading interacts with its shape. But we can also understand why gears amplify torque, or why triangles are strong, or more broadly, how to connect a bunch of pieces together in a strong assembly, or why a smaller shaft results in lower energy loss due to bearing friction. And If we add in a few more models in there, like of stress and buckling, we can see how the overall geometry of a component connects to its failure modes, and then invert those relationships to design really mass-efficient shapes. And if we add in electromechanical and thermal models of motors, we can make these tiny robots that put out a ton of power. So through this experiments, we've seen that these models are incredibly powerful tools for design. And hopefully this has shown us, that's why we asked you to take those prerequisite courses. That's why we taught you those things in the first place, so that you can use that knowledge, um, synthesize it, and apply it to create new things. And as you reflect on this, the experience in this course, hopefully you notice that we started with things you already knew, like statics and stress analysis from your solid mechanics course, and some energy concepts from your physics mechanics course. But then we started to learn and apply some new models of things like buckling, electric motors, gears, other catalog parts. And so what we're learning here is not just a set of tools, although we certainly did, but also this broader approach. And what you'll do next is pick up the models that you need for the next context in which you design. And you'll look for situations when you notice you could really use a model that connects the outcomes you care about to the choices that you get to make as a designer. And keep an eye out especially for generalizable models that are always true. And you add these things to your collection, and the more that you pick up, the more that you learn about the nature of the physical world, the more impressive the things that you'll be able to design will be. And this is really a lifelong process. So you're going to get an opportunity to go deeper and broader in your capstone design course, where you have a lot more time to work on a single design concept, but you'll be picking up and applying new models for new domains throughout your career. So we're almost finished here, and I just wanted to say that I really enjoyed being your lead instructor this quarter. It has been a great experience watching you all grow and learn, and I've also enjoyed learning myself how to teach a bit better in this remote format, and guiding our amazing teacher team as they also learned to teach a little bit better themselves. And I've been really impressed with everybody in the class for different reasons, different times throughout the quarter. And we always have room to grow, of course, but I think you should all be proud of how you've done. I've been looking through your responses to the final survey, and it's been really good to hear that you see how much you've learned, and to hear about how you've coped with the challenges that are inherent to this kind of learning, the hard thinking and struggle that has to happen in order to encode these new skills. And it's been interesting to hear how you've managed those moments with the blank canvas, and or just the daunting technical problem, the complex seeming equation. And I know that even though it was tough at times, you all came out better for it overall. So I hope you'll keep in touch. I'd really like to hear from you about how MU104 gets incorporated into your internships, your next educational experiences, your career, and ways that we can improve the course, things that we should have taught, different ways of thinking about things, and anything that could be helpful for us. Please do keep in touch. So you're going to get one more chance to hang out with your coaching group and celebrate, but I may not see you for a while. So until then, happy designing.